Mr. Hannah here. In this video we're going to be covering our last power function, and it's going to be the power function that involves an x to the power half term. Now for those who know their index laws really well, that is the exact same thing as the square root of x. So what we're really covering here is square root functions. Square root functions. Now, just like I said in one of my earlier videos, you can graph any unfamiliar function by creating a table of values. So let's create a table of values for a function of x being square root of x. Okay, so we'll put in some x values and find what we get out when we do. Alright, so we'll put in some common things that you'll know the answer to. So square root of 0, hopefully you know the square root of 0 is 0. Square root of 1, well that's 1. Square root of 4 is 2. Square root of 9 is 3. And square root of 16 is 4. Now let's go backwards a little bit and think about the square roots of negative 1 and negative 4. Well, hopefully you know you can't have the square root of a negative number. So these are both undefined. Undefined. Okay, so let's go about plotting these points on a set of axes. Okay, so the furthest x value we used was 16, so let's do something like this. So that's 5, 10, 15, that one, 16. Okay, that should be okay. Now for all these negative ones, it's undefined. So for all of these negative numbers out here, there's going to be nothing at all because it's undefined. Now it starts here at 0, so there's going to be at 0, 0. So there's going to be a point at the origin. At 1, we've got a point of 1, so that's here somewhere. 4, we've got a point of 2, 4, 2, something like this. And then at 9, we have 3, 9, we've got 3, and at 16, we've got 4. So that's our 4, 3, 2, 1. Okay, so now we can join up our dots and we can see the shape of this graph. Looks a little bit like that. So we can say that the domain of this graph, so the possible x values, well, it's the positive real numbers and also 0. So the union with 0 because it includes 0. Another way we can say that same thing is we're including 0 and then it goes all the way to positive infinity. So that's the same thing. And our range is actually exactly the same. See, it starts at 0. We can't have negative results, and it can actually keep going as high as we like, but it goes there sort of increasingly slowly. So our range is the exact same as our domain. Okay. Now, just like our other power functions, we can write a general form for the square root function. And it will look like this. Ax minus k. Okay, so you should be getting extremely familiar with this general form with our different powers. So that's why this power is why we call it power functions. So you'll know from this that actually things like quadratics are also power functions that we've already covered. Okay, now from our index laws, that's actually the exact same thing as if we had been writing a square root x minus k plus h. There we go. So now let's just do a few examples using this general form and plotting graphs using it. Okay, here's our first example. Y equals x plus 2 to the power of a half plus 1. Now I just want to note quickly that that could also have been written x plus 2 under the square root sign plus 1. Okay, so this takes the same form as our previous graph. So we notice that there are no reflections or dilations going on. There's no negative sign or number at the front. But it has been shifted up 1, so there are a couple of translations that have been shifted up 1 and to the left 2. To the left 2, up 1. So to find our initial point, it's going to be out here with the -2 and with 1. And so it'll cut through, it'll start there at that point, -2, 1, -2, 1, and it'll be a similar shape to before with no dilations or translations. Now it does have a y-intercept, so we better find that. Y-intercept occurs when x is 0, so that is y-intercept x being 0, so that's 2 to the power 1/2 plus 1. In other words, that is square root 2 plus 1. Now it is absolutely perfectly fine to just leave it in exact form like that. So I'd write root 2 plus 1. If you want to, you can write a decimal approximation, but exact form is almost always better to write. So that's that y-intercept there. Okay, let's move on to our second example. Okay, here's our second example. Y equals negative root x minus 1 plus 2. Now, straight away we can tell we could have written this in a different way. X minus 1 with our power of 1/2 plus 2. Okay, so this time we do have a reflection. It's a reflection in the x-axis because it's out the front of everything. We've also got some translations to the right 1 and up 2. So first let's just sketch what this will look like. So notice, by the way, there are no actual asymptotes here. There's nothing where it approaches a particular value but never hits it, but there is some domain restrictions. So that's a key thing to remember. So it's gone up 2 and across 1, across 1. So it starts here. So that's where it starts. Now it's been reflected in the x-axis. So it's going to be going like this. Okay, so here it's crossing the x-axis, so we need to find the x-axis intercept. So for the x-axis intercept, that's when y equals 0. So that 0 equals negative root x minus 1 plus 2. So we'll subtract 2 from both sides. Now we'll multiply by -1. I'll just shift down, get some more space. Okay. So now we've got a square root. Now obviously the opposite thing to a square root is squared. So, or we could have written this with 1/2. It's the same sort of idea. So we're going to square both sides here. So 2 squared is 4 of x minus 1. Now we'll add 1 to both sides. That gives us 5 equals x. So at this point here, I've clearly drawn this not very well to scale because where it crosses is 5. X equals 5. So there's that example. Okay, so our third example, y equals 3 times minus x to the power 1/2. Now, of course, we can write this in the other way, 3 square root of negative x. So we've got no translations, but we do have a dilation of 3, and we've also got this negative sign. Now, what you're probably thinking is, well, you can't have the square root of a negative number, and that's true. But what if x actually was a negative number? Like if x equaled -4, then this would be the square root of negative minus 4, which would be the square root of 4, which would be 2. Okay, so this is allowed. But it's not sort of in our general form. So what you might be thinking it's possible to rearrange this so it's in our general form, but it's actually not. We can't take the negative sign out of a square root. So here's where we really do need to remember that when the minus sign is in front of x, that is a reflection in the y-axis. Okay, so that's a reflection in the y-axis. So let's Let's plot this one. So I'll plot it over here. Okay, so there's no translations to worry about. So it'll still start at the origin, but it's a reflection in the y-axis. So instead of coming out this way, it will actually be coming out in the other way, reflected across the y-axis. So it'll be more like that. Now, you also notice that we do have this dilation of 3, so we need to put a point on here somewhere so that we take this into account. So because we've already done a little bit of work here, we'll put the point of when x is -4 in. So put this -4 point in, and see what we get out. We get y equals 3, negative -4 to the half. We've already done this bit, and we've discovered that's 2. 3 times 2, which equals 6. So this point here must be 6, so that is -4, 6. And that's all we really need to show the dilation. Okay, so let's put it all together with this example 4, where I put everything in here. We've got a reflection in the x-axis, a dilation, reflection in the y-axis, and 2 translations. So we've got everything. This is as complicated as it can possibly get. Now in this example, I'm going to purposefully make a mistake, and then a common mistake, and then I'm going to show you why, what we have to do properly so that we don't make that mistake ourselves. Okay, so it appears as though we've got a translation up 1, and we've got a +3 there, so it appears as though we've got a translation to the left 3. So if we were to plot this thing, x, y, it would appear as though we would start at 1 and, up 1, I should say, up 1 and to the left. Let's make it here, -3. It appears as though we should start here, -3 and 1, start there, and then do a reflection in the x-axis. So instead of going out that way, we'd be going out this way. But then to also do a reflection in the in the x-axis. So reflection in both axes. So then reflected across the x-axis, going that way. So both reflections happening there. And then making sure there's a dilation of 2 by putting in this x-axis intercept. So our overall graph, we would assume, looks like this. Oh, I've actually made too many mistakes. More mistakes than I meant to make. Obviously this is a -1, so I mean down here. Whoops. So it would actually be starting here and going this way. Sorry about that, I accidentally made more mistakes than I intended to. Okay, now this is actually wrong. Here is a reason why it's wrong. We have not included the point, say, 2. We've not included the point x equals 2. But x equals 2 is included. Because look, if we put x equals 2 into this, x equals 2, we get y equals -2 square root -2 plus 3 minus 1. -2 plus 3 is, of course, 1. So that's the square root of 1, -2 minus 1, and the square root of 1 is 1, so it's -2 minus 1 equals 3. So at that point, there should be a point here at 2 minus 3, and there isn't. So we've obviously made some sort of mistake. And the mistake we've made is, we've started in the wrong spot. This is the wrong spot to start. And this translation here is actually wrong. The reason is that this negative sign here that we've talked about is a reflection in the y-axis, actually needs to be with respect to everything else in the square root. So let me just restart this problem and do it properly this time. Okay, so here we go, and I'm going to do this in 2 different ways to explain it as clearly as I possibly can. So first, let's rearrange this so that this minus sign actually does act as a reflection in the y-axis. So going to be minus 2 and the square root, so the minus, and then we need to take the minus out as a factor, which will change the sign of the plus 3 to minus 3, minus 1. So now we have it right. This minus 1 means we're going down 1 unit. This minus 3 means we're going to the right 3 units. Then we have a reflection in the, so that's, I'm just going to write reflection in the y-axis. This one's reflection in x-axis, and this is a dilation. Okay, so what's going on? But it's reasonably easy to put it all together. So down 1 brings us down to 1 here, minus 1. To the right 3. So this is the point that we start at, 3 minus 1. Now we're reflecting across the x-axis, so instead of going up, reflecting across the x-axis brings us, so instead of being up, we're going to be down, but then there's a reflection against the y-axis, so we're going to be reflecting overall in that direction. So now there's also the dilation of 2, so you need to include a point. Let's include the y-intercept here. So that's when x is 0. Our y-intercept is minus 2 times negative minus 3 minus 1 minus 2. Now this is a square root of 3 minus 1. Now you can't simplify this any further, so we'll just leave it exactly like that. Minus 2 root 3 minus 1. Done. So there we go, we've fully finished this graph. Now the other way to approach this question, let me get a little bit of extra, I'll write it again. So we're approaching minus 2 root negative x plus 3 minus 1. There is another way to sort of approach this, but it involves drawing lots of graphs one after the other. So here you can think, if you want to, and ignore this bit. If the first bit made sense, ignore this bit. Plus 3 does mean going that way, minus 1 down. So our first graph will look like this way 3, so it's minus 3, and downwards 1, minus 1. So our first graph looks like, looks like this. Now we'll take care of this negative, so the x-axis 1. So if we're reflecting across the x-axis, oh sorry, that's the y-axis one. So if we're reflecting across the y-axis, all of these points jump across to there. So here, that minus 3 becomes 3, and the negative 1 stays negative 1. And it will go the other direction. So that is how we do this reflection. And then we can do the negative 2 reflection in a similar way, which will bring us to the next graph of what we had in the first place. Now I recommend just using this method that I did in the first place, where we made sure that we had the negative sign out as a factor. Okay, so best of luck with that.